Here we are in section 4.1 with numbers 9 through 24. Number 9, this is x to the 6th times x cubed. This rule, we're multiplying them. They have the like bases, so 6 and 3 is 9, x to the 9th. Here we have like bases again, so that is 2 cubed times 2 to the 4th equals 2 to the 7th. Again, these numbers don't add. This is 2 times 2 times 2, and this is 2 times 2 times 2 times 2. Notice we have counted up all 7 of them, so we don't end up timesing the bases. We just say, oh, hey, look, there are 7 2's all put together. This rule right here, we are dividing, so we're going to subtract those two exponents, so we get r to the 1, which is just r. Here is a 0 exponent. Now, anything to the 0 power is 1, so this is just a times 1 equals a. Here we are multiplying, which means we are adding exponents. So that gives us y to the negative 2. But that's not simplified. Anything with a negative exponent is, we're not really supposed to leave it like that. So we write 1 over y squared. Ooh, here, this one. I'm going to write this as m to the 8th over m to the negative 5. This is division, so we subtract and we get 8 minus a minus 5. Let's write that up there. 8 minus a minus 5. That is m to the 13th power. You also could have done this as a negative exponent. It moves that up to the top as an m to the 5th times an m to the 8th, and you still get this m to the 13th power. Ooh, 15. This one looks a little bit tougher, but 8k minus 7k is just k. So we have k cubed times k to the negative 9th. This is multiplication, so we can just add the exponents, that's k to the negative 6, and simplify it 1 over k to the 6th. Now the other option you could have done is written it as k cubed over k to the 9th, because that negative would make it go down to the bottom, and then in subtraction you would still get this same answer. Number 16. Okay, let's look at just the x's for a minute. This is division, so we're going to subtract x. 7 minus a minus 4, that's x to the 11th. This guy goes down to the bottom, so we have a y cubed and a z to the 12th. Now notice we could have also done it a different way. I'm going to do it just a little bit differently. I'm going to take care of all the negative exponents first. So that would mean like this guy would go up and that guy would go down. So we would have an x to the 7th, an x to the 4th, over a y to the 3rd, z to the 12th. Taking care of all the negative exponents. Now we've got the rule where these two are multiplying. We add the exponents. You get an 11. And then you get the same answer. Number 17. Here we have t to the 4th times t to the 0. T to the 0 is 1. So this is just t to the 4th. Negative 1 to the 53rd power times negative 1 squared is negative 1 to the, these guys add, and that's 55th power. Now if you actually multiply that out, not just using the rule of exponents, but negative 1 times negative 1, positive 1, times negative 1 is negative 1, times negative 1 is positive 1, you will end up with a negative 1. Number 19, a to the 5th, b cubed times a squared, b to the negative 7. Now this has got 5 a's in it, and it's got 2 a's, and the b's can just kind of switch through the a's. So we end up with a to the 7th, we add those two, and then b cubed and b to the negative 7, that's b to the negative 4th. And what do negative exponents do? They go from here and shove them down to the bottom of the fraction. So we have a to the 7th over b to the 4th. Ooh, look at that. This guy, well, we can do it one of two ways. We can take this and shove it down to the bottom, and we get a 1 over. Now when it goes down to the bottom, we have a 1 over that's left. X to the 7th and x to the 4th, that's x to the 11th. Or we could have done it a different way with the other rules. We could have said, hey, we're in a division problem. This is x to the negative 7 minus 4. That's x to the negative 11, which is shoved down to the bottom, right there again. You'll find out that these rules, depending on how you perceive this problem, if you perceive it as, oh, I've got to take care of the negatives, and then they're multiplying on the bottom, so I'll add, That is the same thing as viewing it as a division problem with subtraction and the negative exponents moving it down to the bottom at the end. It's all the same thing. Number 21, we have h to the 7th. Let's look at the h's here for a minute. Over h to the negative 4. If this is a division problem, we have h to the 7 minus that negative 4, which is going to be h to the 11th. And then here we have f to the negative 3 minus 12. Okay, so that is just division allows us to subtract exponents. So we get h to the 11th, f to the negative 15th, and then this guy, negative exponent, shoves it back down to the bottom, h to the 11th over f to the 15th. That's one way to do it. Now let's just make sure you understand this. You could have done it a different way and taken care of that guy, move up to the top, and that guy moves down to the bottom. So we could have had h to the 7th, h to the 4th, and on the bottom we would have had f to the 12th, f to the 3rd. These two multiply and add, so we get h to the 11th. These two multiply, so you add exponents. We get the exact same thing. So moving the negative exponents or using the subtraction rule, both of them will end you up at the exact same place. Number 22. Q to the negative 8 over q to the negative 12. If we just use the subtraction rule, we get q to the negative 8 minus a minus 12. That is q to the positive 4. If you want to view it differently and take care of those negative exponents, that's fine. You can move that down. You move that up, and you get q to the 12th over q to the 8th. Now, using the subtraction rule, you get q to the 4th. And notice we're the same thing no matter what. Number 23. Here we have a negative 1 to the 7th power. Now think about negative 1 times negative 1 times negative 1 times negative 1. It's all ones, but they keep switching signs, positive to negative. Negative 1 times negative 1 is positive 1. Times negative 1 again, you get negative 1. So this to the 7th power ends up being a negative 1. Times, now, this is division, so we're going to subtract the 4 and the 2. That's 4 minus 2 right there. That's where that guy came from. And so we just get a negative m squared. There we go. Oh boy, this looks like a big one. So let's see what we can get out of here. You know, I think we're going to take care of all the negatives first. I think that might as well just work. So we're going to take this guy. He's going to move down to the bottom as a positive 8. This guy is going to go down as a positive 9. This guy is going to go up as a positive 12. This guy is going to go up as a positive 21. And so let's write that out and see what we get. We get g to the 5th. We've got an r to the 19th. The j went down here, j to the 8th. The o went down here, and o to the 9th. And then we have the b squared down there. And the r cubed right there. R to the 19th, and we still have a e to the 12th, which came up, and an a to the 21st, which came up, and t to the 8th, and e to the 1st, right? That's all on the top. Okay, so let's see what we can combine here. Highlight these guys. The r's, we can do that. Those will be put together, and then the e's can be put together. So let's put the r's together. 19 minus 3, that's division, so we're going to subtract. So we have g to the 5th, r to the 16th. E now is 12 plus 1. We're multiplying, so that's going to be a plus. 13th power. A to the 21st, t to the 8th, and j to the 8th, o to the 9th, and b to the 2nd power. And you will see a sense of humor by one of those folks who made this math book, who has just told you with such a large problem, you have done a great job. Okay, there we go with 9 through 24.